So let's talk about some of the physical properties of alcohols. Now, you should already be familiar with this point that alkanes and hydrocarbons, the CH3, CH2 groups, their intermolecular forces are dispersion forces. So in order for them to actually stick to each other, we need a temporary shift in the electron density. Now, alcohols have an intermolecular force that's present in both them and carboxylic acids, and this intermolecular force is called a hydrogen bond. Now, hydrogen bonding is kind of unique in terms of the intermolecular forces. We talk about it with organic compounds because we always think covalent when we think organic compounds. The reality is a hydrogen bond actually has a degree of ionic character to it. So if we have two alcohol molecules, in this case two 1-propanol molecules come together, what will happen is that one of them will act like a Lewis base and the other will act like a Lewis acid. And we will get these two Lewis structures. So one of these will lose a hydrogen, the other will gain a hydrogen, so this will give us a one with a -1 charge and one with a +1 charge. This looks ionic. Now, they are not doing this in super high quantities, and so we still see what looks like a dipole-dipole interaction here. Oxygen is negative, hydrogen is positive, so we see the two ends sticking together. But what we have above dipole-dipole here is this hydrogen transfer, and this hydrogen transfer is going to increase the strength of the intermolecular force because we are basically forming small amounts of ions that stick to each other better. Now, the way we improve the strength of the hydrogen bonding is to make this carbon more electron withdrawing. So we put something like halogens on it, we pull something like a nitrate, something that's more electronegative than carbon, and start sucking away the electron density. This will increase the strength of the intermolecular forces. But again, keep in mind when we work with alcohols, it's like dipole-dipole plus a degree of ionic behavior. And this is what makes alcohols so much better at sticking together. And this is why they're liquids at higher temperatures than something like a ketone, an aldehyde, or a alkane with a similar molecular weight.